Okay, boys and girls, this is page 272 in your math, and I just wanted to do a couple problems here to show you how to do some of these problems because they're not straight up like the other pages. You might have to do some adding, you might have to do some multiplying, so I'm going to show you 13 and 14. So 13, Hero has 5 kilograms of potatoes and 2 kilograms of onions. He plans to use 3 2500 kilograms of potatoes and 550 grams of onions for a recipe. How many total kilograms of the produce will not be used? Well, first thing, you need to remember the word not. Didn't say how much is he going to use, it says how much is he not going to use. So that's number one, first thing you got to remind yourself of. Second thing, if you go back, King Henry died, and we're dealing with grams, drinking chocolate milk. So how does grams relate to kilograms? Kilo means 1,000. So one of these is going to equal 1,000 grams. Okay, so 1 kilo equals 1,000 grams. Okay, that's what kilo means, 1,000. Like kilometer means 1,000 meters. Kilogram means 1,000 grams. Okay, so 5 kilograms, and he's going to use 3.25. This is for the potatoes. So it's 5 minus 3.25. And what do I always say here? Line up the place values. 5 doesn't have a decimal, but you can add decimal 00 without changing the value. It's still 5. So once again, you subtract. You got to remember here, don't fall for it. 0 minus 5 is not 5. You need to regroup. 10 minus 5 is 5. 9 minus 2 is 7. And we have 1 7/500 kilograms of potatoes. Okay? And that's what he's not going to use. So I'm going to put a little note here, not used, because he plans to use 3.25. So 1.75 kilograms of potatoes is not going to be used. Now, for the onions, it says 2 kilograms of onions. So remember, kilo in front means 1,000, and it says his recipe is going to use 550. So how do you can't go 2 minus 550. But if you realize that kilo means 1,000, 2 kilograms, that means 2,000 grams, because kilo again means 1,000. And he's going to use 550, becomes a very normal subtraction problem. Okay? 9. Oops, I think I borrowed 1 too much. 0. 10 minus 5 is 5. 9 minus 5 is 4. So 1,450 grams is not going to be used here. So this is a trick question. It says they want the answer in kilograms. So 1.75 kilograms is for the potatoes, and 1,450 grams. Okay, that's in grams. But in order to convert that to kilograms, we're gonna, since it's in grams, 1, 2, 3. We're gonna do 3 place value shifts that way. 1, 2, 3. It's 1.45 grams. Okay, and how did I switched 1,450 grams into kilograms? So now this is kilograms and this is kilograms. This is a very complex problem. So add them up, you get 3.2 kilograms of produce will not be used. That was a long problem, okay? But wanted to be sure to do a couple examples. So I'll do number 2 now. Number 2 says, a US nickel has a mass of 5 grams. A US penny has a mass of 2.5 grams, 2.2 grams. What is the mass in kilograms of the coins in a bag containing 186 nickels and 72 pennies? So, I'm not going to do the whole problem, but you're going to have to figure out 186 times 5 and 72 pennies times 2.5. So, to set that up, obviously 186 times, and we can multiply it by 5 wholes because 5.00 is the same as 5 wholes. And that number is going to give you how much 186 nickels is worth. And for the pennies, it's 72 pennies times 2.5. Now remember here, we do have a decimal involved. So when I multiply, I'm going to make sure I put a 1 right there. And let me just go ahead and multiply. Since I know there is one number behind a decimal, I can multiply like normal. 10, 35, 36. Placeholder 4 and 14, and I'm gonna get 0, 10, 7, 8, 1,800. Now that's grams, and this 30. Oops, I forgot the decimal. 180. 30. 40, 43, 930. So this is in grams, but it is asking how many kilograms. So if I add 930 plus 180, I get 1,110. Now this is grams. So how do I convert that into kilograms? Again, go back to my little chart. Since we're at grams and the book, the homework sheet wants kilograms, 1, 2, 3 decimal place moves to express this value in kilograms. So 1, 2, 3. The answer is 1/1100 kilograms. These are definitely a lot of steps, and try your best on them. I did 2 examples for you. Each of these problems, you have to do so many steps. I guess that's why they're called multi-step problem solving. Try your best. They are challenging, but hopefully by walking you through 2 of them, you have better chances of doing 15, 16, or 17. And the only thing I ask is try your best. Alrighty?